Now I am discussing about the lattice enthalpy. What is the lattice enthalpy? Already I told you that in enthalpy of solution, we have enthalpy of solution formula is lattice enthalpy plus delta H hydration enthalpy. Lattice enthalpy means energy required to break the bond. It means it dissociates into its ions. Hydration enthalpy means what is that? Solvent molecules surround to a particular ion, then energy release. Therefore, I want to write the definition. The enthalpy change. Every definition start with this word only. Enthalpy change. Enthalpy change of 1 mole of ionic compound dissociates into its ions in gas phase. Ions mean which one? One is positively charged, another is negatively charged. Positively charged is called cation, negatively charged is called anion. So this is called lattice enthalpy. Its reverse also called lattice enthalpy. When cation and anion combine to form 1 mole of ionic compound, that time energy release. But here energy required. This cation anion leg is attracted to break this cation anion into their respective ion in the gas phase. Energy required. When they combine together, energy release. So lattice enthalpy may be positive or negative. Positive when breakdown into ion. When ions are together to form 1 mole of ionic compound, then that is negative. Keep in mind, lattice enthalpy is positive also, negative also. According to situation, you have to understand. Now, when salt added into the water, that time always lattice enthalpy is positive, because in solvent that ions are separated into cation, anion. Later it is hydrated. That you have to remember. Therefore, now NaCl solid when dissolved into the water, NaCl solid when dissolved into the water, then this will be converted into here water. I want, for your understanding purpose, I am writing this water. Otherwise you can write H2O. Then this will be converted into Na plus aqueous, Cl minus aqueous. Clear? Sorry, I have to write this gas form, not aqueous. If water is there, aqueous correct, but first we have to discuss clearly about the what is lattice enthalpy, because I wrote about according to enthalpy of solution. So now keep in mind, normally only this is a gas according to the definition. Then this value how much? And lattice enthalpy is equal to 788 kilojoule mole inverse. In some books may be given 787.6 also. This roundup value is 788. So it depends upon the which value you are taking in the its individual steps. Now this is the lattice enthalpy. Now we know that according to Hess law, what is the Hess law? The enthalpy change for a reaction is same whether it occur in the single step or series of steps. So according to Hess law, now I want to write Na solid and half Cl2. This is in the form of gas. Now I want to show you that lattice enthalpy of NaCl is 788 kilojoule per mole. So this lattice enthalpy we cannot directly calculate. We can calculate lattice enthalpy can be calculated by indirect method, that is Born-Haber, H-A-B-E-R. If you're not appearing, I am studying here. It means reading H-A-B-E-R, Born-Haber cycle. So lattice enthalpy is calculated by indirect method, Born-Haber cycle. So by using this Born-Haber cycle, we will calculate the lattice enthalpy. So how to calculate the lattice enthalpy? I am showing here step by step process. This is single step. Roman letter 1 I am indicating because according to Hess law, single step is equal to series of step enthalpy change. Then this will be form Na. What do you call? NaCl is dissociate into. So it form NaCl. Then you may ask the question, sir, actually we have to dissociate into Na plus Cl minus, but we took here NaCl, then it form NaCl. Formation and dissociation enthalpy change is same, but sign is opposite, because if this reaction is reverse, Na plus Cl minus combined to form which one? NaCl solid. That time you will get here minus sign, because you know the Laplace law. What is that? Enthalpy change is same with the opposite sign for the reverse reaction. Therefore, for this one, this formed in this delta reaction is equal to minus, because it's formed minus 411 point, because these values you have to remember compulsory for PU board level. This is 411.2 kilojoule mole inverse. Now already in the previous all definition I told her, you may remember or not remember that value, that is not that much important, but in this case for board level compulsory you have to remember this value, and this is very important question for board level. All this from here to that up to end, each and every word you have to write in examination. It looks somewhat lengthy, but you have to remember with values. This is single step. Now Roman letter 2. What is the Roman letter 2? These are single step. Now series of steps. In this series of steps, I want to write this is 1 now. How to convert Na plus Cl minus? We have which one? Na solid. This Na solid first convert into Na gas. When you convert Na solid to gas, energy required. That energy is called, otherwise we can write directly here, that energy called delta sublimation energy. That I want to write delta reaction H1. R mean reaction, H1, first equation. Therefore, this value here 108.4 kilojoule mole inverse. With each point values also you have to remember. This is the first one. Keep in mind why we convert into gas, because we have to make into Na plus. How to make into Na plus? When you remove the electron, that is called ionization enthalpy. Ionization enthalpy definition, you know that when the minimum amount of energy required to remove the electron from outermost orbit in the isolated gaseous atom. So that should be gaseous atom now. Second one is Na gas is converted into which one? Na plus electron. So this is called ionization enthalpy, IE plus ionization enthalpy, energy given. So this is simply represented as IE, ionization enthalpy is, otherwise you can add enthalpy change of reaction. Second, this value is 495.6 kilojoule mole inverse. If you take 0.6, then you will get here answer is 787.6 something. If it is taken as round off and 496, then you will get 788. So it depends what you are taking. So now keep in mind solid current to gas energy required, that's a positive. Then to remove electron energy required, therefore here also positive. Then we got Na plus, because NaCl solid current to Na plus gas, Cl minus gas. So in that one positively charged gaseous form we got. Next one, what is that? Cl minus. So in this third one step is we have Cl2 in the form of gas, that should be converted into Cl in the form of gas, because we have to convert into Cl minus. Cl minus means what is that? When you add electron to any atom, that will be converted into anion. So what is that? Electron gain enthalpy or electron affinity. When you add electron to isolated gaseous atom, energy will be released. But we want 1 Cl, therefore we have to make into half, then here 1 Cl balanced. So this will be gaseous form, then this is known as a bond dissociation enthalpy, because now it is dissociated. Cl bond breakdown and come to single Cl. This will be represented as, and here half is there, therefore here also half. Then here delta R H3, for this also 2, and this total value, already something value is there, the total value I want to write here, half value only, that is 121 kilojoule mole inverse. To break down this Cl bond, here also energy positive. Now one more step is there. Now we got the Cl in the gas form. To this we are adding electron, then this is converted into Cl minus in the form of gas. When electron is added, this may be known as electron affinity enthalpy, otherwise electron gain enthalpy, right? And this is equal to, that is 1 with sodium 2 equation, this third, and this is I think fourth, then this is fourth, sorry, here I have to write R and fourth. This value is minus 348.6 kilojoule mole inverse. Compulsory, these values you have to remember, compulsory. Now we convert into Na plus and Cl minus. Then last one step, this is a fourth point, then this is fifth one. Then Na plus gas plus Cl minus gas combined to form NaCl. This is solid. For this, energy release, because ions are combined to form 1 mole of ionic compound, that time energy release, this is known as lattice enthalpy. What do you call this? Lattice enthalpy. This I want to write delta reaction H5. This is we don't know, but generally when this is what do you call form, then energy will be released. We know this is negative, but how much we don't know. Now all these we have to add. All this we have to add when we know that Roman letter 1 is equal to Roman letter 2. This is single step, this is series of steps. In this, the enthalpy of reaction is equal to which one? All this enthalpy of which one? First, sublimation plus enthalpy of ionization enthalpy and another one is bond dissociation enthalpy, another one is electron affinity, another one is lattice enthalpy. This all sum is equal to single step. Now this can be represented as delta H1, this is delta H2, this is delta H3, this is delta H4, this is delta H5. Now this value we know that minus 411 point. Each and every value you have to remember 411.2 kilojoule mole unit. I am not writing unit, later I will write the unit. So 400, you write in examination 411.2 because it's important for board level also. 411.2 kilojoule per mole. Otherwise I will write, don't worry, kilojoule per mole is equal to delta H1 is 108.4. Later I will write the all total units because it is addition. 108.4 kilojoule per mole. Then next one is 496, round up value I am writing here, and next one is 121. Then here only is there plus and minus, then it is minus 348.6, and this is delta H5 we don't know. Then this totally this is what do you call kilojoule mole inverse. If you add all these values, then delta H5, that is nothing but delta lattice enthalpy, you should add all these value and subtract, then you will get minus 788 kilojoule mole inverse, that is lattice enthalpy. Already I told you that this is negative value, then we got here negative value, you will get common, you do it. Okay, now this can be simply represented in the form of one small flowchart type. Sodium, keep in mind this is Na solid plus Cl, half Cl2, and this is converted into in the form of NaCl solid. This value is first step value, that is delta HR is equal to minus 411.2 kilojoule per mole. Here space not there, that's why I am not writing units. This solid is converted into which one? Na gas. This value is how much? Sublimation value 108. Delta H1 is equal to 108.4 kilojoule per mole. This Na gas converted into Na plus gas, for this enthalpy value is how much? 496 kilojoule per mole. Now this Cl2 is half converted into Cl in the form of gas. This bond dissociation enthalpy, this is 1, 2 means this is 3. This value is 121 kilojoule per mole. For this we are adding electron plus electron, then this is going to Cl minus gaseous form. This value is enthalpy 3 means this is a 4, that equal to minus 348.6. Then all these Na plus Cl minus combined to form which one? NaCl. So for this 1 mark in the board level, and remaining is total 2 marks. Actually definition 1 mark, total calculation 1 mark, and this one total 3 marks in our board level. So now Na plus Cl minus this converted to delta lattice enthalpy. This is we don't know how much. This is how much? Minus 788 kilojoule per mole. Then in enthalpy of solution, how it is reverse? Then lattice enthalpy for dissociation is plus 788 kilojoule mole inverse. In some books 787.6 we will get based on this value. I wrote 496. If 495.6, if then it 787.6. Now enthalpy of solution, if you compare here, then this will be lattice enthalpy and hydration enthalpy. This total value is 788 and this hydration enthalpy is minus 784. Then this equal to minus 4 kilojoule mole inverse. So I hope you understand this. Sorry, here plus, I wrote plus but I wrote minus. So positive value indicating here NaCl soluble. Many of the compound having the enthalpy of solution is positive, but temperature increases, their solubility increases. So keep in mind, many solid compound values are positive, very rare that is negative. If negative is there, that is more soluble, but lower positive value is there, mean to increase the temperature they are more soluble. So temperature increases, their solubility increases. With this, standard enthalpy of lattice enthalpy is completed. But keep in mind, for competitive exam purpose, what they will ask directly, they may ask the lattice enthalpy value. Otherwise, how you will calculate the lattice enthalpy? By using indirect method, that is Born-Haber cycle. Okay, and it may be positive or negative, mean it both positive also, negative also. For formation negative, for dissociation positive. Sometimes directly they may ask this value also. You have to remember lattice enthalpy for NaCl. For other compounds, other value will be there, but in our textbook this is only explained. That's why you have to remember this value. And if board exam is there, and this is very, very important, compulsory, guaranteed question this is. Okay, thank you very much.